In our previous video, you may know what LoRa is. Well, let us compare LoRa with other LPWAN technologies. In this case, we can be more specific about its advantages and disadvantages and the environment in which it can be applied. LoRa and NB-IoT. NB-IoT is a network technology based on the long-term evolution (LTE) standard that provides connectivity in the 200 kHz spectrum. Most IoT applications are currently using this technology because of its good coverage and low deployment cost. The advantages of the NB-IoT standard include the ability to deploy the technology using existing LTE networks, large coverage areas, and high-quality customer service. Similarly, the LoRaWAN standard is characterized by a long communication range and therefore coverage area, long service time for user terminals, low cost of network deployment and user terminals, and high penetration. Although NB-IoT offers large coverage areas and high-quality links, even when implemented using existing LTE networks, the technology is expensive to deploy compared to LoRa, as upgrading existing base stations incurs higher costs. LoRa and IEEE 802.15.4. The IEEE 802.15.4 standard offers data rates close to 250 kbps/s. However, the transmission range depends heavily on the environment. While for a clear line of sight this can be up to 1000 m, in most cases the measurement range is tens of meters. The IEEE 802.15.4 standard supports 3 unlicensed frequency bands, 868 MHz in Europe, 928 MHz in North America, and 2.4 GHz globally. LoRa is less sensitive to interference than IEEE 802.15.4G. Studies of channelization have demonstrated that it is resilient enough to obtain high packet reception rates, PRR, even under strong interference from IEEE 802.15.4G signals, which are transmitted in the same frequency band. The impact of these signals depends heavily on the configuration of the LoRa network, i.e. SF and BW. At high data rates, LoRa can tolerate interference from signals whose amplitude is 6 dB higher than the power of the actual LoRa signal received. LoRa and Sigfox. Sigfox is a proprietary ultra-narrowband technology developed by the company of the same name based in Liège, France, which uses differential binary phase shift keying (DBPSK) modulation. In contrast, modulation using LoRa is based on a proprietary spread spectrum technique and Gaussian frequency shift keying. With the Sigfox network, packets are sent 3 times at random frequencies to maximize the probability of successfully receiving at least one packet, as it is more sensitive to interference than the LoRa network. In coverage and area capability, Sigfox and LoRaWAN covered 150 square kilometers of North Denmark test urban area and found uplink indoor coverage, 20 dB penetration loss. The impact from interference was even worse because the link budget was reduced and LoRaWAN coverage was 78%, while Sigfox coverage was below 50%. Summary of the advantages of LoRa. As you can see from the comparison in the previous section, LoRa has many advantages over other LPWAN networks. The biggest advantages of LoRa deployment in future infrastructure networks are as follows. Low energy consumption. Indoor coverage up to hundreds of meters. High penetration capability of radio signals. Multi-hop solutions with coverage close to tens of kilometers. Outdoor coverage of up to several kilometers for remote communication. After watching this video, you can see that LoRa really makes our lives smarter and smarter. If you want to know more useful information about LoRa, you can click it to follow us.